Okay, great. Hi, everyone. Thanks for coming. It was a long flight from San Francisco all the way here to Beijing, but I'm very happy to be here. Uh, my name is Jonathan Kelley, as everyone mentioned. I'm the creator of Dioxus. Dioxus is a modern app framework that fundamentally rethinks how we build and ship apps for the next billion devices. So something I've asked myself, and maybe you've asked yourself before if you've ever tried to sit down and build an app, is why is modern app development so complex? There are thousands of tutorials online: how to build an iOS app with Swift, how to build an Android app with Java, how to write a REST API with Python. How do you even know where to begin? We have dozens of programming languages, dozens of UI frameworks, and so many libraries just for the simple act of getting our ideas out of our head and into the hands of our friends and potential customers. What if we had a magic wand? What if we could fundamentally rethink how app development works? What if we could radically simplify everything, make it more powerful, make it that much easier for us to think of a new idea and to get it into our hands within 5-10 minutes? So 3 years ago, almost 3 years ago, it's not been quite 3 years, I was in my college dorm room. So I graduated somewhat recently. I was a student, much like many of the people here at this conference, with a real passion for hardware and electronics. I love working on side projects. So I was working on these like really cool AirTag type things. There's like the circuit board for it. There's a bunch of like Rust code on the left. So I did embedded Rust before it was cool. I'm constantly thinking of new project ideas, new startup ideas, new pieces of technology. I love electronics, robotics, manufacturing. Beijing is a cool place for that. Shenzhen, even cooler. But crazy enough, like I'm building these like software-defined radios with GPU accelerated things, or like building these circuit boards. But like always, the hard part was building the apps that wrapped it. And all my apps kind of look pretty ugly. You can kind of see. I always struggled to wrap my ideas in good software. Somehow it was easier to design these complex circuits and get them manufactured and design robotic arms and do inverse kinematics than it was to literally just build an app that wrapped it. So every device I worked on, every new robotic arm or every platform brought new tools, new programming languages, and new levels of complexity. I could learn things forever and still go nowhere. The technology list was endless: Java, Kotlin, Swift, Objective-C, React, Vite. The list goes on and on. Stuff comes in, stuff goes out. You constantly learn new things. So I decided, after building enough side projects, what if we could just rethink modern app development? So I set out to build it. And that's what this Dioxus stuff is. So I went in with a thesis as someone who was not a software person at the time, hardware person. What should app development be? And fundamentally, I was like, this needs to be easy to learn. I want to get up and running quickly. I want to reuse a lot of the knowledge that I've already accumulated over the years. I needed to be able to iterate quickly. Like my ideas changed as I worked on them. I couldn't sit there and wait 12 minutes for a build system. Like a new React Native app that you build it, there's literally 12 minutes of waiting. So you've had your idea, you're going to sit down and build an app, and then you wait for 12 minutes for it to build. That doesn't make sense. And then I needed to be deeply powerful. A lot of the stuff I was doing was very complicated. I can't have to sit through these different levels of abstraction. I need to talk to the system directly. I need to be able to use the functions and tools that the operating system gives me to get my job done. I wanted to iterate on my ideas and not fumble with build scripts and all sorts of UI libraries. So Dioxus was born. Here it is. It's a Rust framework that makes it possible for any developer on Mac, Windows, or Linux to ship apps that run on web, desktop, and mobile, all from a single code base. And literally, like what you're looking at right now, this is a single file. It's 15 lines of code. It takes 42 seconds from like downloading Dioxus to have an app that runs on literally every platform. So it's very quick to get started. We have first-class support for Android, iOS, WebAssembly is how we run on websites, Mac OS, Windows, and Linux, and then all the flavors of Linux that entails. At a glance, we draw from many sources of inspiration. So we use signals for state management. If you're familiar with React or you're familiar with Solid.js, we're pulling a lot of these ideas of how do you architect these applications. State is very simple to work with in Dioxus. We use a special type of pointer in Rust that actually you don't have to call clone on it, you don't have to call copy on it. It's as if you were using just a garbage collected language, which is something we just like pushed into Rust. We've made this happen. You might have heard that Rust is hard to manage memory and it's noisy and complicated. We figured out a way with some limitations to make that really, really simple. Our UI elements are declared using this custom RSX syntax. This draws from Swift UI and Jetpack Compose. We wanted mobile developers to feel at home in Dioxus. It doesn't look like JSX, which is kind of where RSX gets its name from. So it's similar for the web developers that are coming from React or Solid. We chose this specific syntax because it feels at home in Rust tooling specifically. The curly braces are just natural in Rust. You start a curly brace, it closes it automatically. The syntax for callbacks is just the normal Rust closure syntax. Funny enough, like code folding also works out of the box because it's Rust. So all the Rust things that normally like work on Rust code just worked for RSX out of the box. So it's a new syntax, but it's the same thing that you've always used to build things before. We made a bit of a controversial decision to use HTML and CSS as like the base layer. Projects like Flutter will come up with their own design systems. Projects like React Native will lean into the systems and try to abstract on top of it. Me coming from this like hardware background, I learned how to build websites. That was one of the things I knew, and I kind of didn't want to give up that knowledge. I didn't want to learn an entirely new framework and way of laying out widgets and styling them. I just wanted to use the HTML and CSS that I knew. And you can go really far with HTML and CSS. We have some cool examples of stuff that looks native, but it's just done with HTML and CSS. We also benefit from this like AI boom. Like the AI models out there really know HTML and CSS. Like they can pump out Dioxus components, no problem. We have some more AI stuff later in the talk, but we don't have to give it this entirely new system. The models just know how to work with our code. And then finally, we made a choice that our developer tooling is an app in your terminal. So there's no Xcode, there's no Android Studio, there's no dedicated IDE you need to use to build Dioxus. We have developers from all over the world using all sorts of tools. We have NeoVim people, we have Emacs people, we have VS Code people, we have Zed people. We didn't want to make anyone use our tooling. I think that would hurt our adoption if someone had to use the Dioxus editor to build Dioxus apps. It's already a pain to set up Xcode. It's already a pain to set up Android Studio. If you could just like download the Dioxus CLI and then it just works, like that's a magical experience. And once you learn the DX CLI, you can use it anywhere. So you can use it in your continuous integration, your build scripts, if you have to have build scripts. So you learn it once and it runs in every environment. And that DX tool I mentioned is extremely powerful. So, we built it for Dioxus, but it truly is a general purpose runner and packager for cross-platform apps. Like Dioxus, again, is just a library in this big Crates ecosystem. There's 130,000 Rust packages on Crates.io. I think there's like 88 million downloads. Like it's a huge ecosystem. If we stuck with something like Dart or JavaScript, you have these limitations of libraries don't work everywhere. They're not always native in the places you need them to be. So by sticking with this like single Rust architecture, we're able to call DX serve and get our app running like immediately. So you can download Dioxus CLI in literally a second. We do binary installation. So we do pre-built binaries. You can get up and running in like 2 seconds. We'll show it in a little bit. Today, the DX CLI supports web, Mac OS, Windows, Linux, Android, iOS, and literally a week before I came here, someone gave me a Harmony OS phone and said, get this working. So we have very experimental, it's like barely there, but it's on its way, support for Harmony OS. So, we said the next billion devices we want it to be there for. It's obvious a very large fraction of those next billion devices will run Harmony OS. Dioxus compiles to native code. So we don't have a virtual machine. There's no runtime in between you and the system. The things we create, the final artifact is assembly, it's machine code. So it runs on every single major platform. Pretty much every major platform lets you run machine code, and even the ones that don't typically have something like a WebAssembly engine that we can also target, and then it runs there. So on the web, where you're not allowed to run native code, you compile to WebAssembly, which is this sandboxed architecture, and you can run there. So we support those environments as well. Yeah, and with one command, you learn Dioxus CLI once, you can serve for every platform. And it really is as simple as dxserve --platform web, desktop, mobile, Android, all these platforms. The thing I love the most, I'm going to rave about my own tool for a second. The thing I love the most is before, if I wanted to build something like Spotify, right? I need a TV app, I need a mobile app, I need a watch app, I need a backend server. All of these apps are in different programming languages. You need clients for all of these things. So I need to do something like Open API, and then like that limits actually how fast I can iterate that backend service. So I probably need to go hire someone to go build that server, and then I need to like do this people management where like I have to ask this person to add this function to my API. No, I can't ship my side projects. Companies can't ship their products if they're having to build these massive teams to support this. And like you actually see this. So companies like in the United States, we had a company called Clubhouse, and their entire product was like a podcast room. You and your friends could hop in a room, have a live podcast. They never shipped Android support. They built just for iOS, and then they got cloned by everybody, and they lost their market share. So like literally, if you don't have multi-platform support, you'll just get eaten. And they raised billions or millions, hundreds of millions of dollars for that app. So like this is a $100 million mistake. Dioxus enables a single developer to do the work like of an entire team. We don't have to have all these different packages. Literally with one main.rs, we have what would take you hundreds of hours, thousands of hours, weeks, years. And you don't have to deal with the build systems of all these things. So like there's no more updating Gradle, which is a pain in the butt. There's no more build plugins. There's no more debugging JavaScript webpackers and like why some weird ESM syntax doesn't work in this version of this browser. Like we have run into these and we have solved them for ourselves, and you don't have to do that. You just write Dioxus. We've taken all care of the gnarly bits for you. And even a little bit more magically is, too good to be true, but like because we're compiling to native code, we get all of the huge benefits. No one does this anymore. They think it's too hard. It really isn't. When we bundle for the web, these like WebAssembly binaries are less than 50 kilobytes. That fits in like a single full-size TCP/IP packet, like one packet and you've got the app, which admittedly 50 kilobytes is kind of large for the web, but WebAssembly like on the fly that gets interpreted as it's being downloaded, which means by the time your JavaScript is like done downloading, we're already running. And our desktop apps, we don't strip them and do all the fancy stuff, but just like straight out of the box is 3 megabytes. Like that's nothing. Like, I don't know if you've ever sat and downloaded an app on your phone and it's 500 megabytes and like your data plan is just burned through or it took you 10 minutes. A Dioxus app is like an immediate download. So like as a business, if you're trying to ship apps that people, they don't know if they want, people are kind of like, do I want to download this app? A Dioxus app is like, it downloads it instantly. The biggest thing in your app will be your like images. And we have a solution for that too. So also, it's a compiled code. There's no just-in-time compiling. There's no like runtime engine that needs to get hot. There's no aspect of Java where we need to load your classes into memory. And like you set the program counter to start and it goes. There's no startup time. I say less than 100 milliseconds. It's just I can't feasibly time like our time to first paint any faster than that. Like I think on the web it's like a millisecond or something like that. We're also like 10 to 100 times faster than Node.js and Python, which actually is a big deal. So when you go to build a web server, you normally are thinking, I need to be web scale. If your Rust code is 100 times faster than your JavaScript, like you don't have to think about scale until you have 100 times more users, which is like, I don't know, that's the difference between 10,000 users and like a million users. We also are like 10 to 100 times more memory efficient. So on these serverless platforms where you're charged by compute time times memory usage, that's the square. Like not only like you're paying with the square of your compute. So if you run a Dioxus app in the cloud, it's like 100 to 1,000 times less cloud spend. So if you're going to build, a full-sized website, something Rails similar, or like an email client or something like this, and you're doing server-side rendering in an e-commerce store, you are spending 1,000, 10,000 times less in cost, and you can grow to 1,000, 10,000 times larger before you have to think about the things that you are thinking about immediately with these JavaScript runtimes. Like literally a $5 micro container KVM kind of thing, a Fly or an EKS setup will carry you into your company's like huge. You just keep making the machine bigger until scale actually is an issue and you need to buy a rack. But after that, it's still easy. So how does it work? We have a hybrid native HTML renderer. This is a long journey of making it truly native, of course, but because we started with HTML and CSS, we get all the goodies of HTML and CSS. You can either use a web view, which is like the most compatible version of this, or you can use our Blitz project, which Nico will talk about later today. But it means you can use your favorite CSS libraries. You can use modern features like grid, flexbox selectors. The cool thing I like is you can just drop in native widgets. It's not as easy with the WebView-based renderer because you have to get into that compositor level, but you can push any widget you want onto the screen. So I'll show you some examples, but we have cool demos of like, let me do a native file picker, or let me do like a native like calendar selector. So your apps actually do feel like they belong on the platform. We render with the GPU, with our Blitz project or WebView, and something interesting that like libraries like Flutter have a hard time doing is like the entire stack of the web. Modern web, I don't know if you've messed with Next.js these days or any of these Remix, any of these JavaScript frameworks. SEO, server-side rendering, and HTML streaming are these like hard things to get right. It's basically an either or. Do I want something that's cross-platform or good for the web? Because Dioxus is HTML and CSS, you get all of that for free. You get root loaders, you get layouts, you get partial rendering, you get HTML streaming, basically everything that makes Next.js cool, we have to. But we also make native mobile and desktop apps. And as I mentioned, like we have apps that look native but are HTML and CSS. This is a community-made app. It's a Mastodon client called Ibu. It looks just like the Apple Mail. I mean, it even has like transparency. So on the left, like that's the color of the background of like the user's computer. So it fits into the system like a native app. And they have done some things to call some native functions to make it look prettier here and there, but like so that's just something you couldn't do otherwise. We also have hot reloading, all the flavors of it, all in different levels of experimental to like mature support. So you write your markup, you can edit like Rust code. So we're like editing numbers and strings and stuff in our markup, and we're seeing the app update like literally instantly. So this is a hybrid between Rust native hot reloading and then like our markup hot reloading. We also support Rust native hot reloading. This is way more experimental. Hot reloading compiled artifacts is like an infinitely long challenge, but we do have like some runtime support for it, like in the Dioxus virtual DOM that you render. It does support this. So you can also edit just straight up Rust code, and the changes propagate within 300 milliseconds. Which, like a Rust build is, I don't know, a fresh one is 30 seconds, incrementals are 5, and yet we're getting like updates to the screen in less than 300 milliseconds. We are like circumventing all these different layers in the compiler. We're patching symbols and they're running executable in place, but you can actually like hot reload Rust code like as you watch it. It's a pretty incredible feat. What makes this super interesting, like no other mobile framework does this or desktop framework, is we can call like native APIs and we can hot reload those calls to those native APIs. Like I said, a fresh React Native build is 12 minutes. We can do this in 300 milliseconds. So this, I'll go back. This is us, we have some code that is calling a native file picker. So like on your system, this is using what looks and feels familiar. There's no custom widgets that have to do this. We're able to just, the Objective-C code is not that complicated. You just need to call the Objective-C functions. We know how to do that, like Dioxus, the team. If you want to add that, you can contribute to our SDK project, which bundles all of this knowledge into one place. a small amount of platform-specific code can make apps feel way more native, and that's kind of the challenge these days, is how do we make something that's truly cross-platform but also feels like it fits properly? We have an asset system. So whether or not this is that interesting to you, I think it's very interesting because it's very complicated in how it works under the hood, but the way you use it is very simple. When you reference an asset, you use this like macro syntax. If you've used Vite before, this is basically the equivalent of an import. But what this does is in the final executable, so when you write cargo build or cargo run or whatever, the final executable has like this missing hole in it that says this asset is referencing some ID that doesn't exist yet. When we go to build everything, we're able to actually match up those IDs to the assets on your computer. And then when you go to bundle, the references are resolved. So you're able to bundle assets through dependencies. So we have this ability to export hybrid code through dependencies and hybrid assets through dependencies. And because this is all automatic, we can optimize the assets themselves implicitly. So there's this like asset system under the hood where images that would normally have been like 10 megabytes on your homepage, we optimize with the AVIF extension, like that compression library, and we can get them down to like 500 kilobytes. So when we're talking about 50 kilobytes of WebAssembly and your images are megabytes, there's lots of different scales here, but the asset system is able to optimize your sites for CDNs. We're able to do image resizing at compile time. Companies like Vercel make you pay for this as a feature. You pay for runtime asset optimization. We do it when you write cargo build or when you run DX build for free. You're welcome. I said Dioxus is full stack. There are server clients. What does that mean? With Dioxus, you literally you take an async function, get server data, you put server on top of it, and then when this function is compiled, your app is compiled with the server feature, you have a web server with that function exposed as an API endpoint. So you can go to Postman or curl and you can hit that endpoint. But when that function is compiled with the iOS flag, for example, it now is a call to the server. So we don't bundle the server in the app, we bundle the calls to the server. Well, when then you go to use it, so like on line 11 here, you just call get server data.await. So it feels like a function, but that's your server right there. Like embedded in your app, your UI is an entire web server, an entire REST API. There's no multi-language bindings. There's no exposing endpoints. There's no complicated Terraform or Docker or anything you need to write. When you compile Dioxus with the server flag, you get a one file binary that has all the assets in it, has a web server, has rate limiting, has an admin dashboard, it has all the bells and whistles that you'd want of like a modern web framework stack. You get it for free with one extra line in your setup. The cool thing here is it's type safe. So the function arguments that we pass and then the types that we return are guaranteed to serialize and deserialize every time. I worked at Cloudflare. We had a demo we had to get out. We spent a week hunting down a bug and a deserializer and an inserter deep in our infrastructure. 5 people did this. People got paid good money to work on this. Like that cost tens of thousands of dollars, that one little deserialization bug. You get it for free. And it's automatic, and the API is perfectly versioned to every client that you've shipped. So there's never a mismatch between your API v1, API v2, API v3. These functions are bound to the clients that you have in the world. We also have AI. I think I have to include this out of just, you have to these days. But as a side project that became a serious project, because we love side projects, we fine-tuned a Llama 3 model. There's a huge ecosystem of stuff out there, component libraries or different bindings or something like that. And we wanted that for ourselves without having to write that by hand. So we fine-tuned a model that we could basically dump a React library into and get a Dioxus library out of. But you can also prompt it with your own ideas for components. I want a login screen that talks to the Stripe API. That is something the Dioxus AI can do. I'm not going to demo that. It's a lot to set up at the moment, but this is open source. You can go to our GitHub and play with it. It runs locally. We had a requirement that we wanted this to run on our machines. We didn't want to have to make people pay for it right now. Maybe eventually we'll give you you pay us, we'll run it on Grok or something like that, so it's nice and fast. It can also improve your app in place. So performance, accessibility, dark mode, basically all these things that are tedious to get right to make an app feel at home. It will do that for you automatically. So that's not it. We have a huge ecosystem. It's growing by the day. I wish it was more stable. You know, we ship new features all the time. There's a million things, so this is not just it. But we have a multi-platform router. If you're familiar with like app dev, like you're deep in the weeds here, getting those routers right is hard. Ours is multi-platform. It knows how to work on all these different environments. It's compatible with mobile. It does route-based loading for the web. It's very powerful, but it's very niche. So it's a little too narrow for this topic. Integrated logging. So whether you're running on the server, it knows how to talk to things like Prometheus or Sentry. You're running a desktop app, it knows how to talk, report its crash back to the home base. Icon libraries, component libraries, internationalization. People have been building meta frameworks around Dioxus. There's a project I think called Zeno that has like a queue, a mail server, a job system. We have a WGPU-based render, which Nico will talk about later. There's all sorts of stuff. So it's amazing to watch like the ecosystem evolve. We're gonna do something hard. We're gonna build an app here in 5 minutes that does all of the things that we just talked about. So bear with me. And I will cheat a little bit. I pre-wrote some code so we can reference back to it so we don't get lost. It is 35 lines of code, so let's hope we don't get lost, but we'll do this. Cool, so I'm not gonna show you, we have a command called dxnew. It will prompt you through what you want out of your app. I'm not gonna go through that right now because I'm not sure I have connection to GitHub. It will pull templates from GitHub. So we have like an e-commerce template. We have like a social media template. We have different types of templates you can use. We're just gonna go with the vanilla one for now. There's nothing special about this. Every Rust app has a cargo.toml. This is like a dependencies file. It tells you like what dependencies are in their app. We only have Dioxus for today. We're turning on the full stack feature, which means we're going to be able to write server functions. You don't have to include it. Like when you're building these apps, we're going to leave it on. And then we expose the different platforms we want. So we're going to do a true multi-platform app today. We have web, desktop, mobile. So we actually need to re-export these features so our tools can pick it up. Cool. This is, can everybody see this? Is this too small? Is it big? Good? Should I, all right. Oh, all right. Take serve. So we're gonna do, yeah, we'll do mobile. I think that's fun. We get to see a mobile app for today. Unfortunately, you can't see my, all right. I'll give it a second. So we have our mobile simulator over here. We have this IDE in the terminal. It is like literally animated. The little spinners spin. There's like progress bars. We have instructions on how to like mess with the app. So we can edit the app live. So let's go into here. Hello, GOSIM. And then you can see the app updates live in real time. It's a little small, so we're gonna do a thing real quick. We're gonna bundle in a style sheet, so head style sheet. I'll just let autocomplete. Because this asset has never been included in the bundle, we have to do a full reload. That was a very fast reload, but now we have text centered in the screen. We're gonna, let's do a thing real quick. We're gonna add some buttons. So button on click. Actually, what we want is it to add some state. So we're gonna do mute day equals the signal 0. And then we're gonna day plus equals 1. Next day. and then we're gonna render this, so day. All right, I'm just gonna rebuild real quick. Cool, so we have a counter, we have a button. When we press it, the count goes up. That's pretty cool. We need to style the button. It looks kind of ugly. Let's go look at our style sheet real quick. We have this assets folder. We have a main.css. So this is the CSS I pre-made for this, so we don't have to go and sit and watch us do it together. But we can actually look and we can edit the CSS live. So we're gonna call this button new city. So we have a button style, which is kicking in right now. Let's call this, let's give it a class. Class new city. Ooh. All right, this might be ID. New city. All right, so the style sheet kicked in immediately because there's hot reloading of the style of the assets and the rest code. Let's go to our main.css. I don't know if I like blue. I think I might like green or yellow. No, like green is better. And then we'll add a button to reset it. So we'll say reset city, reset day. Okay. So now we have new city, reset city. Now this is red. We were able to hot reload the code here because it's actually not new Rust code, but we'll say data.set 0. And then we're going to have to do a rebuild. And we can go up here. Let's add a server function real quick. So we'll say let mute city equals use resource. And then we're going to add a server function real quick. I'm running out of time a little bit, but async fn. So this is what a server function would be. If we were going to write it, we're going to pass in some day count into it. In this case, we're going to put it in this use resource. Use resource basically says there's some async that I want. I want it to be in line with the component when I go to render the component, and I want it to be ready before I go to use it. So talking to the server is asynchronous. So we're going to wait just in this tiny little context to get that from the server. We'll put this here, hello from the server, a toString. And then we're gonna do div. Yeah, we'll just let AI. Oops. Yeah, cool. So to get values out of resources like this, we call .value. This extra calling convention here is basically saying get the value out of the resource. You can also use .cloned. It just so happens that the syntax works out that you can call it twice because it's a function actually, the resources are. So we're saying hello from the server. Right now, this is not doing anything special, but we can create a list of phrases. So that cities equals Beck, London, Prague, Shanghai. And then we're gonna do something. We're just gonna cities.iter. .cycle.nth day.unwrap. So what this will do is we'll cycle through the cities as many times as the days are, and then we'll just return that from the server. So we'll save this. We should get our rebuild real quick. It's also reloading the server in place. And now, when we hit next day, we see the city changes as we click. It's pretty cool. So every time that value changes, our reactivity actually goes to the server, does the recalculation, and then comes back. So not only do we have reactivity on the client, we're threading that reactivity through the server, which is, that's like impossible to do in any other framework. What we can also do is mimic a database, I think, which would be a cool little exercise here. So we'll do, let's stdfs read to string, yeah, cities.database. We don't have a cities.database. We'll just pull our cities out of this good one. So if I were going to create a database, I would do something like this. Just a file, like a list. Either we use a SQLite database, we'd set up a Postgres, or Mongo, pick your favorite database. My favorite database is a file. I like to back that up to S3 and I call it a day. Usually some JSON. We'll reload this. And then cities. Cities. And then we can't do we can't iter cities, we have to do lines. Then we should get our results. Like that. Cool. So I think I can just cycle. Yeah. So now these are being loaded from the file. The cool thing here is now that this is a database, we can also hot reload that. So that file, we can come in here and we can say San Francisco. and then I can cycle Barcelona, San Francisco. So cool, so we built a mobile app in like 5 minutes that has server functions, has a database. Can we do it with a desktop app? I think so. Let me kill the simulator real quick. Yeah, so we have a desktop app. That took, what, 5 seconds to build? Let's do it with the web real quick. I think that'd be fun. You have to run some WASM bindgen stuff. You have to build the WASM. Yeah, I see. It doesn't open it for you automatically, but we can do that. And then we have a web app. So boom, so you have every platform. You have web, desktop, mobile, Android, iOS, all in one code base. So that's it. That's that app. I think we are getting low on time here, but we'll come back. Who's using Dioxus? China is, apparently. They're like 22% of our users, and we don't have Chinese docs. The entire world is, happily enough, but it's huge in China. We're 21,000 stars deep into this, 20,000 stars almost. We got backed by Y Combinator like last year, so we actually have some funding. We were sponsored by GitHub also, fortunately. So we're like one of the few companies that are like GitHub accelerator, AI, blah, blah, blah. We did that last year. Now it's an AI focused thing, but before AI was cool, we were there. We're very fortunate, actually. We have a ton of community contributions. There's quite a bit relative to like the scale of the project. Almost 1,500 pull requests over the past 2.5 years. There are a number of cool open source projects. So Airbus and the European Space Agency have collaborated on a satellite collision avoidance system in Dioxus. I did not expect that when I saw it, but it was like super cool. Cloudflare has a high-performance log analytics tool for their mobile app. NC State University has like this robotics like control visualization front-end tool, which is really cool. Bionic GPT has a ChatGPT like front-end written in Dioxus, and it does all the multi-platform stuff. There's Solana, like official Solana adapter, so you can build your distributed DeFi apps around it. Not every app people build with Dioxus is open source, so this is just the stuff we know about. But we have all sorts of companies contributing to Dioxus. I didn't know until I looked like 10 days ago. A ton of the world's top companies have made pull requests and added features and fixed bugs and reported bugs. So we have quite the resume of people that have contributed. What's coming next? I wanted to show you deploy. I wanted to type dx deploy and get our app up onto the App Store. Didn't have enough time, unfortunately. We don't have it yet, so it has to come together. The road on mobile is long and hard. Android is kind of annoying to interface with from Rust, so we have to do that. Stabilizing and WASM binary patching. So I showed you we have Rust hot reloading, which I showed you a video of. We don't have it in the CLI. It's a very experimental feature. We want to stabilize that for the web and then also do bundle splitting on the web. So to tear apart your executable into the most efficient packets and then send that back down. That way you get these incremental repatching. And then tutorial videos, documentation, internationalization, translations, making it more global. Yeah, so that's it. Thank you for sitting through my talk.